Okay, engineers, let's develop the formulas. This is the first formula, the definition of the Laplace transform. We have already seen two formulas, other two formulas. Now, the Laplace transform of 0 is equal to 0, okay? And the Laplace transform of this, the Laplace transform of, I'm going to combine the, the scalar and the addition of subtraction is going to be alpha, which is any number, times f of t, then plus minus beta g of t is going to be equal to alpha, the Laplace transform of f of t, plus minus, sorry for this, plus beta, the Laplace transform of g of t. Now these two formulas comprises the linearity property. The linearity property you can take outside the scalars, and you can do make the property, the distributive property of the functions. All right. Okay. Now let's see other formulas. So let's start with the Laplace transform of the value of t. All right. Okay. Because we don't have formulas, then we have to do it by the definition. So the definition is going to be the integral from 0 to infinite exponential minus st, and whatever you have here goes here. All right. So is t differential of t. So this is just the integral from 0 to infinite t exponential minus st differential of t. All right. Now to solve this integral, we have to do integration by parts. So let's choose this u and then this to be differential of v. So u is equal to t. So differential of u is differential of t, and differential of v is equal to the exponential minus st differential of t. So if you apply the integrals, then it's going to be v, and here you have to complete the integral, so it's going to be minus 1 over s exponential minus st, and that's it. All right. Okay, so let's continue over here. So this is just the formulas of the integration by parts. Okay. So according to the formula of the integration by parts, is going to be u times v, t times minus 1 over s exponential minus st from 0 to infinite. Don't forget that these integrals are defined integrals, and then minus the integral of v minus 1 over s exponential minus st differential of u, which is just differential of t from 0 to infinite. All right. Okay. Let's do some operations here. Minus 1 over s t exponential minus st from 0 to infinite, and then minus times minus positive. The s can be taken outside. Don't forget that here the variable is t, all right, and the s, it doesn't matter what is the value of t, the s is different. So it's going to be the integral of the from 0 to infinite exponential minus st differential of t. Okay, now let's do the upper limit minus the lower limit. If you remember, this is going to be minus 1 over s, then the upper limit infinite times exponential minus infinite minus the lower limit 0 exponential of minus 0. Okay, so this is just for this part. Upper limit minus the lower limit, and then plus 1 over s. Integral of this, you have to complete the integral, so this is going to be minus s differential of t, and then you compensate that with minus 1 over s. So this becomes negative, and then this becomes s squared because of this multiplication. All right. Integral of that exponential is just exponential minus st, and then from 0 to infinite. And you have to do also the upper limit minus the lower limit. Now, how much is exponential minus infinite? Exponential minus infinite happens to be 0. Why it is 0? Remember, the plot of the exponential is like this. So this side is minus infinite, so it's going to be 0. Alright, so that is just to remember what is the exponential of minus infinite is equal to 0. Keep in mind that value. And the exponential of 0 is 1. Okay, so this exponential minus infinite is 0. 0 times infinite It doesn't matter how big is this value. Anything times 0 becomes 0. And this is also 0. 0 times anything is 0. So all these number happens to be just 0. It doesn't matter. So the only thing left is the minus 1 over s squared. Exponential minus st. Let's do the upper limit minus the lower limit. Minus exponential minus infinite. Infinite times s is still infinite, and then minus exponential of minus 0. Okay, this exponential minus infinite is 0, and this exponential of 0 happens to be just 1. Now minus times minus, this is equal to 1 over s squared. Now from where this comes from? This comes from the integral of t. The Laplace transform of t. So here is another formula. The Laplace transform of t is just 1 over s squared. Alright. Okay, let's make the Laplace transform of t squared. Let's see what happens. Alright. So by definition, again, this is going to be integral from 0 to infinite exponential minus st, and then here t squared differential of t. Okay, so let's do this. Integral from 0 to infinite t squared exponential minus st differential of t. We have to apply again integration by parts, and it looks like we have to do it to apply twice because this t squared. So this is going to be u, this is going to be dv. So u is equal to t squared, differential of u is 2t differential of t. dv is equal to the exponential minus st, differential of t. So v is equal to minus 1 over s, exponential minus st, if you apply the integral here. Okay, if we apply the integration by parts formula, then this is going to be equal to what? It's going to be u times v minus t squared over s. If you do this multiplication, this times this, minus t squared over s exponential minus st minus the integral of v differential of u minus 1 over s exponential minus st differential of u to t differential of t. Okay, don't forget this is from 0 to infinite, so that means that this should be evaluated from 0 to infinite. Okay, so let's do the upper limit minus the lower limit. Equal to minus infinite squared, just give more room, minus infinite squared over s exponential minus infinite. So that is the upper limit minus the lower limit 0 squared over s exponential of 0. Okay, and then minus times minus positive 1 over s, integral of the 2 also goes outside, number 2 here, or s, integral from 0 to infinite, and then exponential minus st, and then the t differential of t. Now, have you seen this before? Yes, it is actually this one. Let me remark here. It's actually this one. Exactly the same. T exponential minus st differential of t. It is actually the definition of the Laplace transform, of t. Interesting. Now, how much is this value? This infinite square is a big number, but what about this one? Exponential minus infinite is 0, and this is 0, so all this is just 0. That cancels. Okay, so the Laplace transform of t squared happens to be 2 over s, the Laplace transform, because this is the Laplace transform of t. And what is the Laplace transform of t? Now this is this one. What is the Laplace transform of t? 1 over s squared. So let's just replace 2 over s times 1 over s squared. So this is going to be just 2 over s to the power 3. And that is the Laplace transform of t squared. Now, check here, engineers. Here's a rule. Here the t is power 1 and this is power 2. Okay, now here the power is 2 squared and here is 3. Alright? Okay, so how much is going to be the Laplace transform of t to the power of 3? Okay, so if this is 3, then this should be how much? S to the power of 4. Alright? But what is the number here now? Check this out. This is 1, and here you have 1. This is 2, now you have 2. Now, because this is 3, you should have 3. However, you have to multiply the previous, because this is 2 times 1. So this is going to be 2, 3 times 2 times 1. Alright? Now, what if you have the Laplace transform of t to the power of 4? Now, here is a rule. Because here you have 4, then it's going to be s to the power of 5. And then this is going to be 4 times 3 times 2 times 1. Now, why this multiplication of numbers? Because of the integration by parts. Here, in this integration by parts, you generate 1. But here in this integration by parts, you generate these 2. In the next integration by part is going to be t to the power of 3. When you do the integration by parts, then it's going to be t to the power of 3. So differential of u is going to be t to the power of 3. So differential of u is 3 t squared differential of t. So this 3 is here, alright, in a multiplication. So it's going to be something like that. Now, the general formula. In general, the Laplace transform of t to the power of n is going to be n factorial, if you see, 2 times 1 times 2 times 3 times 4 and so on, divided by the s to the power of n plus 1, because it is always one number ahead, one integer ahead. Okay, so that is the Laplace transform. The definition, well, the formula to get the Laplace transform of any t to the power of n. And just keep in mind here that this n should be integer, 2, 3, 5, 4, and so on. Alright? Now, next video we are going to cover more functions.